DevOps is everywhere these days, and almost all application development, maintenance, and release management make use of the DevOps processes. Without DevOps, application lifecycle cannot be managed these days. As a cybersecurity architect, what is essential for you to understand is that the Microsoft Cybersecurity Reference Architecture and Cloud Security Benchmark offer guidelines and best practices for securing DevOps processes. These processes ensure that security is integrated into every phase of the DevOps lifecycle, from planning and development to deployment and operations. There are 7 key DevOps processes that are prescribed in the Microsoft Cloud Security Benchmark. You can see those 7 processes displayed on the screen. Understanding what each of them covers is highly essential for you to perform risk assessment of the development lifecycle. So let's understand each of them in details. The first one is conduct threat modeling. What is threat modeling? Threat modeling is the process of identifying, analyzing, and mitigating potential security threats in an application or system during the design phase. It helps in proactively addressing security risks before they can be exploited. What considerations would be given in this process? You understand the system and map out the architecture, data flows, and components to identify potential vulnerabilities. You identify threats for which you use frameworks like Stride. You also plan to mitigate risk and prioritize and implement mitigations for identified threats. As mentioned, you make use of the Microsoft Threat Modeling Tool or questionnaire. Microsoft Threat Modeling Tool will help in building threat models, identifying potential security issues, and suggesting mitigations. You make use of the questionnaire when you cannot use Threat Modeling Tool. But remember, to derive the meaning out of the questionnaire, you must be expert in this case. Second DevOps process is ensure software supply chain security. Software supply chain security involves protecting the integrity of software components, especially third-party libraries, to prevent vulnerabilities from being introduced into the application. What are the essential considerations need to be given in this DevOps process? You ensure that component verification is performed and all components or libraries are from trusted sources. You ensure that bill of material is maintained and track all dependencies and versions to quickly address any vulnerabilities. You also ensure that there are processes to update components or libraries regularly with the latest security patches. There are a number of tools that can be used in this case, but at high level, I would like to highlight 2 of them that are mostly used for maintaining supply chain security. One is Azure DevOps Artifact and second one is JFrog Artifactory. If you do not understand how these tools are useful, please go ahead and do some Googling and understand the application of these tools. So definitely I would like to encourage you to invest some time and understand these tools to maintain the supply chain security. Because of the tools, libraries or utilities that are consumed over the open internet, rollout of such mechanism is essential in the secure environment. Third DevOps process is secure DevOps infrastructure. Securing the infrastructure that supports your DevOps processes such as build servers, repositories, and deployment pipelines is crucial for preventing unauthorized access and attacks. What are the considerations in this case you should be giving? First is access control, means ensure that you are maintaining the DevOps infrastructure with corporate identity. If there is a need for you to build federation, then please do so. Such as if you work with GitHub, then you may end up building the federation with GitHub using your identity store, whereas it's a bit easy when it comes to the Azure DevOps. Usually when people start using any Git platform, they start using Git platform hosted agents for their CI/CD platform. The problem with those agents is that they cannot freely communicate with your corporate private resources just like that. You might end up applying some firewall treatment in that case, or you end up deploying self-hosted agents within your network. And when you deploy self-hosted agent in your network, there are multiple design patterns. So ensuring that appropriate design pattern is chosen in this case is a key. Whether to use the Git platform hosted agent or self-hosted agent is all depends on the data classification that you are securing. Be an advisor in this case, because usually developer community cannot understand the implications behind this. And of course, when you hosting your self-hosted agents, then ensure that there is a process around managing patches on those self-hosted agents if they are hosted on Azure VM or any kind of virtual machine. As I mentioned, self-hosted agents and Microsoft Defender for Cloud will help you as a tool to secure DevOps infrastructure. Please remember, Git platform hosted agent is not suitable in all the use cases. And this is where you as a cybersecurity architect ensure that you playing a role of advisory. Fourth, DevOps processes integrate static application security testing into DevOps pipeline. SAST involves analyzing source code for security vulnerabilities before the code is executed. It's essential to integrate SAST into the DevOps pipeline to catch issues early. SAST stands for Static Application Security Testing. What are the considerations that you can provide in this process? You automate scans and integrate SAST tools into CI/CD pipeline to automatically scan code with every commit. You ensure the tools covers all aspects of the code base, including third-party libraries. You also provide clear remediation instructions for any vulnerabilities found to the developer. What tools that you can use for SAST? If you are using GitHub, then you can use GitHub advanced security capabilities that identify vulnerabilities in code, or you can use SonarQube or Checkmarks, which provide detailed static code analysis and integrate seamlessly with Azure DevOps. Fifth, DevOps processes integrate dynamic application security testing into DevOps pipeline. Dust involves testing or running application for vulnerabilities by simulating real-world attacks. This testing is crucial for identifying issues that may not be visible in static code. DART stands for Dynamic Application Security Testing. What are the considerations in this case to be given? You can run Dust on a staging environment that mirrors production. You also integrate Dust tools into the CI/CD pipeline to test with every deployment. You can use both SAS and Dust for comprehensive security coverage. From tools perspective, you can use OAS Zap, which is integrated with Azure DevOps, which is an open source tool that can be integrated into Azure DevOps for Dust. Microsoft Defender for Cloud provides security posture management and advanced threat protection across your workloads. 6. DevOps processes enforce security of workload throughout DevOps lifecycle. This involves ensuring security controls are consistently applied throughout the DevOps lifecycle, from development to deployment and ongoing operations. What are the considerations that need to be given in this case? You promote the use of IAC tools to define and enforce security controls as code. You monitor and enforce compliance with security policies throughout the lifecycle. You implement automated security checks and remediations. For tools, you make use of Azure Policy, which enforces security policies across all your Azure resources. You also make use of Azure Blueprints, which allows you to define and deploy a repeatable set of Azure resources that adhere to your organization's security requirements. 7. DevOps processes enable logging and monitoring in DevOps. Logging and monitoring are critical for detecting and responding to security incidents. By enabling logging, you can track activities and quickly identify suspicious behavior. What are the considerations in this regard to be given? You aggregate logs from all DevOps tools and environment into a central system. You implement real-time monitoring to detect and respond to incidents promptly. You define log retention policies to meet compliance and auditing requirements. What tools that you can use? Azure Monitor provides a full-stack monitoring, advanced analytics, and intelligent insight. Azure Log Analytics aggregates and analyzes logs from various sources, which allow you for detailed analysis and alerting. So overall, integrating these DevOps security processes within your application deployment processes will ensure a secure and compliant software development lifecycle. Using tools from the Azure and Microsoft ecosystem, organization can implement these controls effectively, which reduce the risk of security breaches and ensure continuous security throughout the DevOps pipeline.